Well, good afternoon. Uh, this is, well, maybe it is, maybe it isn't. Let's see. Yes, this is Comp 620 and Comp 422, Information Privacy and Security. And today we are talking about social engineering. Reminder of the schedule. Yes, you are here talking about design principles, social engineering. On Monday, don't come here on Monday. It is fall break. No classes on Monday. Also, Monday is the last day to drop a class. And Friday of this week, Friday the 18th, is when faculty have to post midterm grades. So I have to get my grading done by then. I am flogging my TAs to finish it. It takes many hours to grade 97 students, and we're working on it. We got a lot graded. We still need to get more graded. You cannot see the exam on Blackboard right now, but you will be able to see it shortly when we have the grades posted. I will email everyone a copy of all the grades, including the letter grade for the semester, so they know how they're doing. Yes, question. Oh, the one that had better than 100? I'll check into it. Remember, Blackboard is just a kind of a hint at what your grades are doing. It doesn't average everything correctly. I will be sending you an email where everything is averaged exactly correct. I have to drop the lowest assignment, not the lowest exam, lowest assignment, and remember that the assignments all together, dropping the lowest and averaged out, count for 20% of your grade, and each exam counts for 20% of your grade. I'll try to see if I can't get Blackboard to average them better. Also, one of the assignments is split into a 60-point assignment and a 40-point assignment. I've merged them together into a 100-point assignment, but it looks like I'll check. It should look like 100 points out there. Okay, thank you. I'll work on that. Let's see. Week from, well, on the 28th, we've got talking about election security in time for the election the week after. We also have a guest speaker who will not speak about election security, but we talk about industrial strength security. And then 2 weeks from today is a wellness day, no classes. All right. Social engineering. Social engineering has been going on for millennia. It's a confidence game. You try to convince people to do something that they probably shouldn't do. Basically, you're trying to convince them to give you information. The easiest way to get somebody's password is to ask them, what is your password? And be amazed at a number of times they will tell you, particularly if you convince them that you're not who you are, but that you're somebody important, that oh yes, you ought to give them the password. So it's very common. Big part of the problem is a lot of users who are not computer savvy often make bad decisions. I love this box, reformat drive C. Well, a lot of people will click OK because they always click OK. So they'll click OK, and that, of course, will wipe out their system. Many users have insecure passwords. We talked about that. It's not very hard at all to hack into a system if you guess the first 100,000 most common passwords, and you're likely to get in. Most users don't know the cybersecurity stuff that we're trying to learn in this class. We're going to talk about phishing. Phishing is sending of email or phone or text messages in an attempt to get people to tell you something that they probably should not tell you, usually masquerading as a trustworthy entity. Phishing is where you spray out these emails to lots and lots of people. It doesn't cost hardly anything to send email. So you can work on your system and you can send emails to hundreds of thousands of people. I'm kind of a spam king. I can easily send email to everybody in the class. I'm going to do that again with your grades. I've done that with other groups of people. Easy to email lots of people. If my email was asking for information that they shouldn't divulge, that would be a phishing attack sent to everybody. Spear phishing is when you target somebody in particular, somebody who you might have information about. you send a targeted email message or to that person. If you know that person has a particular job position, you may know who their boss is. You can send an email saying you are their boss, so you can more likely, it looks very targeted towards that person, and they're more likely to accept it. Also, you're looking at people who may have the information that you want. So again, spear phishing is targeted at specifics, or maybe targeted at particular companies. Instead of sending out to everybody, you may be hitting many different people in the company that know something that you want to know. Whaling is just a version of spear phishing where you're aiming at people who have a high position in the company, who may know information that you really would like to know. Somebody with lots of privileges. It may be a senior executive, or it may be the system administrator who has lots of privileges. And if you know how to get into their account, you know lots of stuff. And clone phishing is a version where you're sending them a legitimate email, which has an attached file, but you're not sending them the real attached file. You've got, also notice it is possible to spoof, actually it's quite easy to spoof the return address. When you set up your email address in Outlook or whatever you're using, often you have to say, my return address is this. Well, if it's not that, it still works. Phishing is very effective. 95% of all enterprise networks have had phishing attacks on them. Phishing attempts have grown 65% in the last year. I think that's a couple of years old, so let's just go. 3/4 of the businesses report being victims. Somebody's done that. And 3% of people who get phishing emails read them. And 12% of them click on the malicious links. So they're very effective. You send out 100 of them, you're likely to get 12 people to click on it. That's pretty good. And there are lots and lots of new, not only phishing emails, but people have phishing sites. Often a phishing email will redirect a user to a particular site that looks like the site they might want to visit, but in fact is a duplicate that collects their information. Phishing is usually the beginning of most cyber attacks. You have ransomware, any others, they start with a phishing email. If you read the newspaper about this big attack, it almost always starts with, well, they found somebody who told them something they shouldn't have told them. If you saw the introductory quote, it's all you have to do is get one employee who doesn't understand what to do, tell the attacker their email, and they're in. It's amazing how much they spend on every phishing email that comes in. Every phishing email that comes to an organization takes time from your IT people to recognize it, to get rid of it, and that costs money. Somebody suggested that the company should expect to spend $15 million on recovering from phishing attacks. Also, social networks, Facebook and all the others. Now, many of these have worked very hard to try to protect you against phishing, but they still, it appears, all over the social networks. And again, very high rate of success. Here, somebody showed 70% rate of attack. That's really good. You send out again 100 attacks and you get 70 success. That's, if you're an attacker, that's great. People have been doing it for quite some time. Way back in 1987, somebody described it at a user group meeting. 1990s, there was a phishing attack made against AOL, America Online. That way back in the 90s, people were using phone modems, and many people were connecting to the AOL system. First one against the bank was 2003, which is only 21 years ago. And then WannaCry, that was a big one. That's probably not the biggest anymore. That impacted 230,000 people. And let's be international. That meant to be in 150 countries. That meant the people who did the phishing attack had to take their email and translate it to dozens of different languages. These people really worked at it. This is still, that's 2015. That's, it's 9 years ago. But you can see the growth in phishing. And I couldn't find a more recent graph, but it just goes up and up and up. People are doing a lot of phishing. And again, you can do phishing not only with your computer, but your phone. You get phone calls. I get phone calls all the time telling me that they're from Social Security. I'm old, so you probably don't get phone calls from Social Security. They call me and say, "Oh, we need this information." The hell they do. Look, Social Security, they know that information. They know it. They don't need my Social Security number. They gave me the Social Security number, so they don't need that. You get that information, ask for things. You might get text messages. Text messages are also SMS, small message system. So text messages is an SMS message. And so there's SMS phishing or smishing. Somebody had a lot of fun making up names. Target, spear phishing, whaling, smishing. Okay. And then there were a lot of scams that offered $1,000. I think they were Walmart gift cards. And people were getting messages all the time. Do this. Of course, they didn't exist. Here is the famous son of a Nigerian banker email. This is the phishing attack. This was from years ago, but this is everybody got a dozen of these a day. I remember I was at a chairs meeting and the dean comes in and tells us, no more problems with our budget this year. He's got a Nigerian banker who's going to send us some money. So this is, again, that one, there's another one. This is a concept you see often. They want to know your account number and your password. Mind you, if your bank sent it to you, they know your account number. That's not very convincing. This looks a little bit better. This is, the typical HTML email. It's got a logo, it's better font, and it tells you, oh, there's a problem. Usually, of course, they tell you you have to act immediately. It's almost always important that you do something quickly. I got this one recently. They want, excuse me, let's stop doing that. They click here, link above, remove this quickly, yes. And the link goes to here. What? That's not my email management team. Folks at A&T do not call themselves the email management team. So here comes our first clicker question of the day. All right. Okay. Cards are up. That phone is ready. Okay. We have. Okay. Online folks, 70% of online thought it was C. There's obviously no real answer. This is an opinion question. I think it's D, the greatest threat. Most of the serious attacks start with a phishing attack. Ransomware is a big threat. People are losing a lot of money to ransomware. We'll talk more about that later, but ransomware often starts with a phishing attack. Many of the attacks start with a phishing attack. So I think phishing attacks probably rank as the greatest threat. They aren't in themselves taking them, but they start. Okay, moving on. Maybe. There we go. Now, one thing, I've talked about this before, one thing you can do in an email is you can have an email that displays like that, www.nice.com, but that's not where it goes when you click on it. In this case, it goes to www.evil.com. You have this is HTML, a hyperlink reference goes to this, and it displays that. It doesn't have to display the same thing. And so it will go to where the link says. So if you click on this, it's not going to go to that site. So obviously an attacker will put a happy message up front, and then you click on it and it goes someplace else. If you mouse over that, in most cases, you can look down in the lower left-hand corner on the status bar of your browser, and it will tell you where that link is going. Or sometimes if you mouse over the link, that link's not, well, you show the other ones, it pop up, tells you where it's going to go. I haven't figured out how to do that on my phone. Anybody figure out how to find the destination of a link on their phone? Well, if you do, let me know. I haven't figured it out. I mentioned this before. At A&T, the faculty and staff, people who have the ncat.edu email, not the aggies.ncat.edu. The Aggies email goes through Gmail. Gmail bought somebody paid somebody some money to run the Aggie email. The faculty and staff go through an email system, completely separate email system run by the IT department here at A&T. We have a Microsoft Exchange server, and that server looks at all your emails, looks at the links, and modifies them to send it to a safe link server. So if you click on a link in your email, it goes first to safe links, which looks at where is this link supposed to go. And if it's in a list of known troublesome sites, it will send you an error message. Right, big, bright error message you can't miss. It tells you this is dangerous. Do you really want to go to this? You still have the option of saying, yes, you do, but you should not. And it's part of Microsoft's advanced threat protection system. It's easy to make a website that looks like somebody else's website. If you go to a website, right-click, look at the menu option. One of them is copy. You can copy the page to your local directory. In Chrome, at least, it will copy that page and all the pages that it references. The images will be copied. The cascading style sheets will be copied. The JavaScript files that you need will all be copied. So you have a complete copy of that web page and all the little files that it needs. And then if you are a malicious attacker, all you need to do is put that on your server and direct users to that web page, which looks, of course, exactly like the web page. An alternate means of doing this is to have a pass-through system where you somehow direct users. So I'll get to that, I guess, next slide. But if you have a fake website, and you can have a certificate for that. And so HTTPS will go right to it, doesn't care, because if they have a certificate for their fake site, you go to it, certificates match, everything goes fine, keep going. Similar names is one thing. People will change one of the letters in the name, particularly O's and zeros or L's and ones. In some fonts, a 1 and a lowercase l look exactly the same. So it's easy, of course, they're different. There's also man-in-the-middle websites. I don't know why it's not women in the middle, by the way, but that's the name it's called. Man-in-the-middle attacks, where you direct users to your website. Your website simply passes the request through to the legitimate website, which in return returns some information, which the attacker's website forwards back to you. So it looks and acts just like the real website because it's going to the real website. But as information goes through, the malicious, basically it's a proxy, is picking out the information that they want. They are capturing credit card numbers and also passwords and account numbers so they can log in later. You don't have to be a real computer expert to do this. There's the universal man-in-the-middle phishing kit, which you can buy online. That's what the dark web is for. And so you can go out there and buy these things and run it yourself. Yes. We've seen the dark web. They do sell all sorts of things that you shouldn't buy. You can do cross-site scripting phishing that directs people to a false website, that directs them to a malicious website where they attack in the manner I just described. Of course, it looks exactly the same. It may be the same. And they're recording all the information that you passed to that. Now, what do you do about all this? Some technical things you can do. Look at Padlet. In other words, when you hover over a link, does it go where you want it to go? Does the bottom of the browser tell you, or is it going to someplace that probably shouldn't? User training, user education is the big one. You've got to train the people not to just go clicking all over the place when they get something. Is this likely to be real? Is this likely, from a likely address? Is the people sending it somebody you expect to send you? You can also filter things out. At A&T, the websites, and also Aggies, there's a lot of email filtering. You don't get all the emails that were sent to you. Any known phishing attacks or any known malware is stopped by the email system before it ever arrives in your inbox. I can't remember how much it used to be. 90% of the email was filtered out, but now it's a much lower number, down to 40% or something. One of the ways people can avoid that, the malware can avoid that, is instead of putting the text as text in email, they put it in an image. They have a PNG file or a JPEG image in the email with the text in the file. So you're reading the text, but there is no text in the email. So the filtering system that's looking for disturbing text doesn't see it, just sees a picture. Sometimes they're getting a little clever now. The security systems, the picture, they'll do optical character recognition on the picture, see if they can read any words in there and detect that something's not. And there's also Adobe Flash, and they can, it messes that, and that's called, of course, everybody's having fun with the phishing is flashing. And again, one of the big problems is that users will frequently click things when they shouldn't. If you go to some site and it has an incorrect certificate, you try to click through it and then, oh, the certificate. Now that would occur if you had an attacking website, somebody's trying to put a proxy out there, doesn't know how to do it well. Then you get a message. Somebody go, oh, well, yeah, it's okay, just because you're not going to go if you don't click okay. Unfortunately, some organizations, maybe some that we are sitting in right now, have been known to have problems with their certificates. It hasn't happened recently, but a couple of years ago, they were having all sorts of certificate problems. Anytime you went to an A&T website, it would pop up a message. You'd have to say, ignore that. People get used to ignoring these error messages, which is very bad because then when the real problem occurs, they ignore it. Okay, how do you know a phishing message when you see one? Often they come from other countries. They've been either mechanically translated or translated by somebody who's not a native English speaker, and it has poor grammar. Where does it come from? Now, again, the return address may be obscured, but if it's coming from someplace that isn't like, if you're getting a message from the A&T email system, it'll come from an A&T email. It won't come from a Gmail account. That's not going to happen. Same thing from your banks. You're not going to get a Gmail account from your bank. It's going to be from, firstnational.com. If you have a link, the link is going to go to that organization. If you got a message from Acme and it asks you to click on something, it's going to go to acme.com. It's not going to go to someplace. Common site are the survey sites. It's very easy to make a survey that looks like a legitimate phone. It asks you for your name, it asks you for your email address, it asks you for your account number and password and stuff like that. And then the survey system very nicely stores it in a file, and next day the attacker goes out and picks up all the information that they collected. Again, yeah, check where links go to. And remember, real emails know about you. If you get an email from your bank, it's not going to ask your account number. They know your account number. So they're not going to ask for that sort of stuff. They know your name and all sorts of that. Here's an example email. Take a quick look at this. There's several giveaways in this thing. Right? Here's the things I found. To who? It's not me. From somebody in Canada, no less. Yes. Emails from other countries dealing with a business inside the United States, particularly if it's an A&T. This is not going to come from another country. Canada seems pretty safe, but dear email user, no, it was the real people. They'd send it to you. It would have your name there. Your mailbox has exceeded storage limit. That's not very good grammar. Where does this click go? I didn't show you this, but does that go to some? And then webmail help desk. No. It would come from A&T, and they identify themselves. So one of the things you do is, again, try to make your logins better. two-factor law, two-factor authentication, we talked about this earlier, other things you can do to make your logins more secure. One site I go to, when you go to it, and you enter your user ID, before it says your password, it prints out a phrase that you have given it. If you don't see the right phrase, then you shouldn't log in. So you give it the user ID, it gives you your personal phrase, and if you see that, then you give it the password. That way, if somebody has a fake website, you send your user ID, they will not know what phrase to send to you. Of course, if they know your user ID, they can go to the website, find out what the phrase is. But that's okay. This is something. There's been some attempts at legislation to fight phishing for reasons that I don't understand at all. The Congress has never pulled it together and managed to pass legislation. Well, that's a pretty standard statement, isn't it? They haven't been able to pull together and pass legislation that does anything useful, but they haven't been able to pass legislation to protect customers against phishing. There have been some successful attempts. They've been able to sue people for stealing credit cards, for doing things that are illegal no matter how they do it. So, and again, somebody was found guilty of sending thousands of emails to online AOL, that was years ago, posing as AOL ability department. Please send your email. But I've used this cartoon before. I love it. Community users are usually their greatest problem. Most users don't protect themselves well. If you're in a company and you have to protect the organization's computing, you have to keep the users to be aware of phishing attacks. That's it for phishing. Any questions about that? And we'll move on. There is more. Where's the button? Just a minute. And then let's see if we can show the people online. There you go. You should be able to see the website now. I kind of like that. Take a look at that quote for a minute. That applies to all sorts of situations. Okay. Talk about secure software development. How do vulnerabilities get into the software? Borrowed several slides from Dr. Yuan. This is a nearly random selection of her slides and my slides. Okay, well, as programmers, you are the cause of the vulnerabilities in the software. You write software that does not protect itself against the common attacks and even the not so common attacks. It's your programs that make your organization vulnerable. On the other hand, by doing it correctly, by writing software that protects against the common attacks, you're the solution. There's a growing problem of people attacking software. There's all sorts of holes. We've talked about several of the problems in this class. We'll be talking about more. And more people are creating software that's not as safe as it should be. Here in our computer science department, we used to have the secure software engineering track. It got gobbled up by the software engineering track in master's degree. There are multiple classes in secure software engineering offered by the A&T Computer Science Department. Therefore, I'm not going to cover too much of it today or for the rest of the semester. I used to talk about it for a couple of days, and I just thought, why bother? If you want to know about that stuff, take the other class Dr. Yuan teaches me. I taught half of her class one year when she broke her leg, and I had to fill in for her. She's got several secure software engineering classes. She knows a lot about it. I don't. Okay. Basically, secure software engineering is just applying the good software engineering principles to avoiding vulnerabilities. If you avoid your standard problems in generating software, you will generally keep your system safe. There's a reason why things are not as safe as we'd like. Again, trying to keep it safe is not as sure. We haven't been trying to do that as carefully as we have for other systems. Operating systems have been around since the dawn of computing, so have networks. For those of the gray beard, we'll remember long ago and far away when computers were accessed through punch cards. Yeah, I used a lot of punch cards. And almost nobody got access to the computer room. You had to put in your card and put in your code and walk past the operator who would know who you are. And if you weren't, wasn't going to let you in. And so we didn't make systems secure because we didn't think there was much of a threat. That's because you only use the computers that you had to maintain. Now, people have computers and people from all over the World Wide Web are logging in using a computer. You have no idea who they are. And so it's a much more dangerous situation. So another reason is in-house development. People are developing their software in their business. They know what they want. Everything's unique. Every piece of software they create is something different. If everybody bought their software from someplace, it might look consistent, but it doesn't. And everybody thinks it's easy. How to create a powerful web application from scratch. Well, there's all sorts of systems out there that'll help you do this. It's not hard. You can develop quite an advanced web application in an afternoon. There are also systems that'll help you do that. But they don't always produce secure systems. People think that they've got something, but it's not secure. Basically, secure software engineering is good software engineering. If you develop software that operates without any errors, it's likely to be secure. Program bugs, software design failures introduce vulnerabilities in your software. Big thing is you got to start thinking about security early in the software. We'll talk about that in just a minute. You have to understand the common problems. In this course, my goal is to try to teach you all the common problems. We'll be talking about SQL injection and XSS and XS, pick your letters and whatever we talked about, all these problems. So you know what they are. You need to design for, so you can think about that when you design a software system. Put security in at every level as your design requirements. When you specify what is this software supposed to do, you talk about to your end users, trying to define what it is they want. Security ought to be part of that discussion. In the design, you have to make it design. Implementation, when the coders are out there writing it, they have to know how to write software that is secure. And then installation and maintenance are also very important. It's interesting design. Nice chart, got this from IBM. What does it cost to fix a defect that's a security defect? Well, if you figure out, that's not going to work in the design phase, there's a cost of 1 unit, whatever the units are. If while you're implementing it, you go, that's going to be a problem, it costs 6.5 times more to fix it. If while you're testing the system, okay, you've got it built, you're ready to deploy it, and you're running it through some tests, if you test, it's 15 times. I might point out, we had a event here at A&T that had local app developers come in and looking for people to hire. And I talked to them about testing. Testing, they don't do no testing. Their customers will tell them if it doesn't work. They didn't do any testing at all. Security, it wasn't a problem for them. They didn't get paid for security. They got paid to deliver. And of course, maintenance. That means after it's been out in the field and people are using it, and then you find out there's a bug, it costs a lot to get that fixed. Where should you fix it? They asked a bunch of developers and a bunch of security teams, where the security teams, they tended to mirror each other. Almost everybody says requirements and planning are very important, as where it should be. Application design, interesting in application development, the developers thought it was more important there, and the security people thought less. But yes, you can see, following the cost, everybody thinks you ought to do it early. There are a bunch of reasons why the problem is growing. Our systems are more and more interconnected. Systems talk to other systems to do things. You call APIs on other systems to get something done. Everything is networked together. Sometimes you've got legacy systems and new systems working together. That makes it a little bit more complicated. Extensions. We got all the software that you're putting in. Not only do you, and of course, you want to use all the tools that are available. You don't want to reinvent the wheel. So you go out there and you pick up all these packages. And so you might be using several different packages together, some of which may not be real compatible that you don't notice until you way out later on using it. And so that causes a problem. And then complexity. Complexity makes things difficult. Things tend to get bigger and bigger. The larger and more difficult it is, the harder it is to tell that it's secure. All right. And here comes the question. This is an easy one. You should know this one. There. Okay, everybody's got it. Got to go on. Oh, we got a mixture of opinions here. All right, online. Oh, well, it just changed. I'll be able to report it online. Okay, don't have a big participation online. But most people were going for A. C was also very popular. I think the answer we really want to see is design. Again, if you go back to, oops, B. Stop sharing. Oh, come on. Where does it cost? You want to fix things early, because if you discover a problem later on, it's going to cost more to fix it. Okay, risks. Software security is part of risk management. There's always a risk. You can't really fix everything. Sometimes it's very expensive to make your software very secure. How secure does it need to be? How likely is this problem going to occur? And if it does, what is the impact of that fault? Some faults don't have a big impact, but they may be very likely. Others are not very likely, but they may have a big impact. The things that you really want to worry about are the things that are very likely and have a big impact. And of course, there's many ways to fix this. One, of course, is writing the software correctly. There is non-technical and non-technical means, keeping things secure, not letting your secure code, your source code out. So you want to design it secure. There are people in business work on risk management all the time. That's what keeps the company going. They make sure that they're going to protect things. They look at what is the risk, and therefore, how important is it? I have this little matrix here. Some things are easy to begin. It's not usually easy, difficult. There's usually a scale, like 1 to 5. How easy is it to fix? How difficult it is to fix? And then how likely is it to occur and unlikely? And again, it may not be a binary decision. It may be a scale. But obviously, the things that are very likely to occur and are easy to fix, you fix those first. The things that are unlikely to occur and difficult, you fix those last. You want to go where you get the most improvement for your effort. Here is somebody's list. Oh, I can't remember who made this list. I think I'll claim I stole this from Dr. Yuan. But here's a list of what's effective in doing this. Code reviews. Code reviews, of course, come very beginning. They find somebody writes something, and you look at it and go, oh, that's vulnerable to cross-site scripting. You know that. Architectural risk. Pen testing. Pen testing is trying to break into your system, trying to get in. Risk-based security tests, use cases, security requirements. That would be early. Unfortunately, some of these things, security requirements comes in early. And it may not be as effective, but it has a low cost. I wanted to show you this one. I know for most of you, 2002, you probably weren't even born, but way back in 2000s, 2001, 2000, Microsoft was getting known for having software that was unsecure. They had a very bad reputation for security, that everybody was moving to Apple or moving to Linux because you wouldn't put your stuff on a Microsoft system. It was too vulnerable. So Bill Gates, the CEO of Microsoft, the founder of Microsoft, decided we've got to do something. So he wrote this important memo. They stopped everything they were doing and had everybody go to security training. Right? They shut down development, shut down all the stuff they were doing. And said, okay, everybody, you've got to learn how to do this properly. And he spent more than 2,000 worker days. That's a lot. I mean, spent a lot of money on it. That's $2,002, by the way. They made sure that security was a critical factor in their testing, in their design, every step along the way. They got tools to help them do this. And it helped. They become much more secure than they were back then. And they managed to correct the perception that they were an insecure organization, which has cost them a lot in business. Got the statistic about companies releasing insecure code. We have asking development managers, head of development operations, combine these developers, managers. Well, do you think you release, or developers, do you think you release software that has insecure code? Well, the developers thought maybe 9% of the time they did. Well, yes, it's still got that vulnerability, but there's always pressure to get the software out on a deadline, so they're going to release it. They always thought that, these group of people. But when you combine it all together, you'll notice that about 20% of the time, they think there's nothing wrong with it. But 20% of the time, they think, yes, we have a known problem with this software, but we're going to release it anyway because they want to release on a deadline. And then there's the sometimes. So you add this, and you find over 50% of the time, they're putting secure out there, or they might have some bugs in. Okay, I got another clicker question here. Let's see if we can get the questions to appear. Right? Everybody should see the questions now. I gotta be able to see it. There we go. All right. Okay. A is the number one answer. Oh, I shouldn't have said that. Yeah, look at everybody change their mind online. Sure. Stop in that. Okay. Yes, that's. Yes, I like A. I like A because, well, first of all, let's sort them by repair effort or sort them by danger. A is the most dangerous one. Sort them repair. Well, B is the easiest to repair, but that doesn't buy you much if you repair that one. So, but A has a big danger, and it's moderately, it's about the average of these to repair. So you want to work on the problem A first, because that's likely to cause a lot of trouble, and it's not as difficult as others. In other words, if you're spending the repair time 3, well, this was only danger of 2. This one is a little less dangerous than A, and it costs a lot more effort to repair. Some things are difficult to repair because the problem is built right into the design. Again, where did you find the error? If it's a coding mistake, well, that's easy to fix. If, though, it's a design flaw, it may be much more difficult to fix. There are static analysis tools. Those are tools that go out and look at your source code and say, oh, This is likely to be a problem. It reads, now that's known as white box testing. Static code analysis just looks at code. Now, if you give it your source code, it reads the source code and produces a report saying, this looks like it could have some problem here. Oh, you're using a dangerous function over here. There are a whole bunch of functions in C that are dangerous, that do not do balance checking at all. I'm not going to go over them because I've decided that that's not this class, but they cause lots of problems. The static code analysis will look at these and say, oh, you're using the getS function here. It reads a string and puts it into an array and doesn't care how big that array is. It just puts all the data it has into that array. And if it flows over the end, too bad. We'll talk more about that on Wednesday next week. Again, this is not right. Dynamic code analysis runs the code and tries to determine if it's doing anything that's dangerous. There's a whole bunch of tools to do that. Now, there are pros and cons of static code. First thing, it's easy to do. You can take that program and feed it your whole source code library, everything that you've got, that your company has written, and it can produce reports and all of it. And it's easy. One person can do this and identifies well-known vulnerabilities, things that are well-known, and tells you where the problems are. It'll tell you in this file, on this line, you're doing something that's problematic. And then you can get people out to fix that. Although it's based on the ability of this program to understand what the other program is doing. Another problem is that tools are limited. They don't find all the flaws that you can. I've noticed a high number of false positives. I tried this. I ran some of my code against some of the static code analysis tools, and they're telling me there's a problem when I know it's not a problem, but it doesn't recognize why that's not a problem. And of course, it's difficult to prove that a security issue is actually a vulnerability or it's not. It's not so much a problem of this software. I think early in the semester, we mentioned that it's somewhat impossible to prove what another program is doing or will do. There's the halting problem in computer science where you can't even tell if another program will ever come to an end. Likewise, you can't always tell if it's ever going to execute a different line or something. So in general, it's a very difficult problem. And of course, when you build your applications, it's not only the code that you wrote, but it's all the libraries that you call. They may have vulnerabilities, and you may be using them in a vulnerable way. Fuzz testing is a way of testing software. It's very easy. It just sends lots of bad input to your system and sees how it reacts. You can send random values. You can send what are known to be unexpected values. If it says enter an 8-digit ID, well, you enter a 9, 10, 20-character ID and see what it does. So one of the values of it is it's very simple, but it only finds simple faults. And try to, again, one of the things you might do is throw at the system the simple SQL injection problems that you know. Throw out the, if you go through my slides, you find the examples for cross-site scripting and SQL injection, and you put that in your fuzz set and it sends that to the system just to see if it does anything. And again, there are code, not only static checkers like I talked about, but there are dynamic checkers that run the program and look at it. They also go through some of the libraries. Here's a list of some of them. RATS, which is quite popular. Some of them run in like Fortify. That's a commercial one. You have to pay for that. There may be a trial version or a simple educational version for that. And I like yet another source code analyzer, Yaska, which is a front end to RATS. All right, here's a simple question. Okay. Oh, wait. I'm doing something wrong. There. Okay, now you got it. Okay, we have a tie between C and D. And that is probably appropriate because when do they release it? About 20% of the time, companies know that there's something insecure. But then when there's might be something, you add those together was 50%. So C and D are both good answers. People who answered B weren't paying attention. Okay. Oh, I have to say something when I pick up my phone and do this. It reminds me that I spent some money at a store as I drove to campus this afternoon. That's a feature most of your credit cards will do. If you spend more than a target level that you can set, it will send you a text message telling you you spent so much money at this company at this time. That's really nice to keep your card secure, because if somebody ever gets hold of your card, and I foolishly lost my card about a week ago, if it gets spent, you'll know immediately if somebody's spending money on your card. Of course, they don't have to physically have your card, they just have to have your numbers in them. That'll work. And I also might say, if you lose your card, it's a real bother trying to go out and change all the organizations that automatically charge your card for whatever reason they're doing that, and tell them the number is different. Some companies are very easy, some companies are just a pain. Okay, I went out to the CERT Secure Coding Initiative website and got their top 10 secure coding problems, and I have 10 more slides that goes over each of them. They're good things to know. Again, there are websites out there that give a lot of information about secure coding. We talked about OWASP. This is an acronym for OWASP.org. The S is for secure. Okay. W is for web. I can't remember what the rest. Open web, something security. Okay, doesn't matter. OWASP.org gives you lots of information on keeping your system secure. So does CERT. CERT is a government-sponsored organization for computer emergency response team, I think, part of it. Okay. Define security requirements. I think we mentioned early on that as you start to develop software, think about what are the security requirements? What should you want? And what should it do if there are security problems? Some systems just, security, a halt. That may not be a good operation. You have to do something that keeps the system safe. You want the people who are following after the requirements, the developers, the planners, the architects, they should know what you want it to do. Threat models. We talked about all those threats, identify them, figure out how is your system going to respond to all these threats. That, particularly think about the ones we've talked about, cross-site scripting, SQL injection, et cetera, et cetera. How is your software going to react to these things? And again, risk ranking. What are the most important threats? How expensive are they to protect against? And think about them in all different levels of software development. Validated input. We've talked about this in multiple occasions in this class. You've got to watch out for input coming from, users, or it might not just come from users. It might come from other sites. If you get information from a website, you go off. If your application executes an API on another website, gets information back, you want to make sure that that's not going to bother your system. Again, be suspicious of things. Don't ever execute user input. Again, validate it. We've talked about checking it for good characters and other, checking to make sure that it looks correct. And again, it's not very simple checks can detect a lot of errors. Also, software development, it always helps to detect errors early, because then you can figure out where it's correct. Sometimes if you get a bad value, you store it away, and your program uses it later on and then blows up, it's hard to tell what went wrong. It's much easier that if you get a bad value, you go, oh, bad value. When you write software, there's in most languages, C, Java, Python, there's an assert statement. And the assert statement claims that you make a Boolean effect, something like, A is greater than this, or input is less than, input is greater than 0 and input is less than 10. If that statement is not true, your software will stop. If you have the execution flag saying stop on these. During production, you don't stop, but during development, you have it set. So if these assert statements are tripped, your software will stop and you can go, oh, we detected an error here, we can fix it. So you do that during the, and it costs you almost nothing. If you've turned off the execution parameter to check on assert statements, it costs you almost nothing to have the assert statements in there. So they're not a problem. They don't hurt performance. They won't do anything during development. Excuse me. They will not cause the system to crash during production, but they will help you to find and detect all sorts of errors. So assert statements. Oh, I think you just said this. Sanitized data sent. This is the opposite. Not only do you watch out for what's coming in, but look at what you're sending out. Are you sending out information that might have sensitive information, personally identifiable information? That should not be going out to sites unless it is the purpose of sending that information. That's it. Watch out where you put this stuff. Heed compiler warnings. When you compile something, you'll get error messages and the system will stop when you get an error message and won't go on. And sometimes you get warning message. And a lot of students and professional developers, it's only a warning, I don't care. And I must admit, every now and again, there is a warning that you can't really get around, that the compiler was just confused. But generally, if you get a warning, do something about it. Warning is telling you something's not right. So go out there and fix that. Also, many of the compilers these days have security warnings. They'll tell you, oh, you're doing this. This could cause a security problem. It's a warning. It's not an error. Your software will still compile. You can still run it. But if you get a warning, heed the warning. Do something about it. And again, I mentioned there's dangerous functions. Don't use dangerous. Use something that's much more secure. Keep it simple. Keep it simple and small. I love this quote at the bottom. Software can be simple so there are no problems are obvious, or complex so no problems are obvious. You want to keep it so people can read it. Usual rule they always said is a method should be no more than a page of code so you can understand what it's saying. People need to be able to read it. If it becomes very complex and people don't understand what it's doing, it's very hard for people to understand what it's doing and know if it's doing something insecure. So you want to keep it simple. Simplicity tends to make not only does it make it more secure, it's far less likely that there are bugs in the system. Now, admittedly, some software systems do complex things, but you can break them down to simpler steps that produce a complex result. And you want to keep things simple so it's much more likely to be correct and be secure. Default deny. I think we mentioned this before in class, but by default, you make sure that people don't have access. If nothing else specifies about whether they should have access, the answer is they don't have access. Deny it. And fail securely. When something goes wrong, make sure you leave it in a secure state. Here's an example I've just made up. Assume is admin in some Boolean value, set to true. You are the admin. Then the try-catch, if you're not familiar with try-catch blocks, it means if something occurs in here, you'll jump down here and do something about it. Sometimes in languages like Java, you have to use a try-catch block if the software whatever method you're using it claims it's going to be able to throw an error, throw an exception. If the documentation or the header for software says it's going to throw an exception, then your software has to catch that. So you'll have catch. I have seen graduate students try catch blocks, and the catch block was empty. They did an error, they just did nothing. They thought their software was working just fine because they never got an error message. Of course, they didn't get an error message because they were catching the error and then doing nothing about it. You should at least print it. In this case, we're showing they're going to write a message to the log, which is the least you should do. So again, code which may fail, whatever that statement is, that's some sort of code in here that may, and then they have, if regular user, admin is false. Well, what happens? If this code does fault, generate an exception, you go down here, you write the error message, and you go on. Well, you didn't get to setting the admin, so by default, the admin value is true. You should flip this around. Set the admin value to false. And then check it's not a regular user, set it to true. And we've mentioned this multiple times, the principle of least privilege. Give users and applications only as much privilege as they need. Don't give everybody, don't run everything under root, root being the master administrator password, because it can do, the root user can do everything. Applications do not need to do everything. Also, if you're running an application, so say a web server, web servers will, and other applications, web server, your SQL system, these all run under their own user ID. Give them a user ID that only has the privileges that it needs to do that sort of stuff. Don't give them all sorts of privileges. Just give them the ones that they need. So if somehow the system is tricked into doing something, they can't do those things they shouldn't do. And of course, most of these things do not need to run at a privilege level. They can run at a simple user level. Remember, think that external systems are insecure. It's kind of like not trusting the inputs. You got to trust input. Wait, this is, I guess, kind of a repeat to me. And third-party systems can be compromised. Security in depth. That means don't rely on just one check. Have multiple checks throughout your system to make sure that you're keeping things secure. So if somehow the attacker gets around one layer of your security, something else will catch them. And fix the problem securely. Often, as they say, the quick fix becomes the permanent fix. Something is going wrong, coder goes, oh yeah, we can fix that. Yep. System's back up and running, good. But you need to make a good fix, something that is valid, that doesn't cause other problems. One of the things Microsoft did when they had problems with reliability is they now have extensive testing. It doesn't mean everything works well. I'm dealing with a Microsoft problem that won't go away, and I think they caused it. But when they make a fix, they make a change, they test it against all sorts of previous input to make sure that it keeps on working, that they haven't broken anything. And then quality assurance. Make sure that they do everything as they should, do all sorts of testing, do all sorts of security reviews, make sure external, you can hire people who will go out and inspect your software and see if it's secure. That's often a good idea because sometimes people in-house, they don't really want to find any errors because it makes them look bad. So, but if you get somebody from the outside, their job is to find errors. And so if they don't find anything, it makes them look bad. So they want to find something. All right, that's it for software engineering. Again, computer science department has many courses in secure software engineering. If you're interested in that sort of stuff, I recommend you take them. Dr. Yuan teaches a bunch. Here's the schedule coming up. You are here. We just finished up on design principles. No class on Monday. Do not come here. Do not get on the Zoom on Monday. So, by the way, if I don't start Zoom and you log into Zoom, I get an email telling me you did it. So I'm going to know you forgot. So, all right. A week from today, we're going to be talking about malware and buffer overflow. And, oh, yes, on Monday is also the last day to drop a class. That's the last day where you can drop a class and not get a grade. If you go to Tuesday, you're in it. You can't get out. So you either get a grade, we're going to get a grade. On Friday, that October 18th, that is the Friday, that's in 2 days from now, I have to post midterm grades. And so we are working very hard to get your second exam graded by then. I've got my part of the exam graded, but I'm still pushing the TAs to get their work done. Fortunately, one of the TAs is defending his dissertation this week, so he's busy. We're working on that. Note, by the way, 2 weeks from today is Wellness Day. There is no classes on Wellness Day, no class on Monday, but yeah, 1 day a week. Also, we have a guest speaker. All right, that's it. That's all for today. Any questions? All right, then. That's it.
Have a good one.
You too.